Hey, and welcome to this course where you can get to grips with that maybe bizarre looking __init___.py file. So first things first, I will refer to that file as the dunder init.py file. That should make things a little bit easier. So what will be your rewards for successfully completing this course? Well, firstly, there will be dunder magic, of course, like all dunder objects. Dunder init.py has some built-in magic, and you will find out exactly what that is. Now, if you don't believe in magic, but if learning about the inner workings of Python appeals to you, then you are also in the correct place, because you will get your hands dirty with some code and you see how to implement that magic that you no longer believe in. And then finally, and I should warn you, there is a spoiler in this slide, you will learn about the relationship between dunder init.py and packages. In this course, you'll learn what dunder init.py is, what it does, and how you can use it. Is there any useful knowledge you should have before taking this course? Well, given that you and I will be creating a package, it's best that you have a basic understanding of modules and packages. And also, if importing modules is completely new to you, then you might want to brush up on that knowledge a little bit. Now, luckily for you, I've included some helpful links in the resources section to get you going. So in this course, you'll first spend some time getting to know dunder init.py, and then you will move on to managing the public interface of your package. Now, that's exciting stuff. Well, at least I think so. So I can't wait to get going, and I hope to see you in the next lesson. So in this lesson, you'll get a quick introduction into dunder init.py before diving into some examples later in the course. So what is dunder init.py? Well, it ends with .py, so therefore it's a module, but it starts with 2 underscores and ends with 2 underscores. So that's a dunder module, if you like. So that makes it a magic module. Now, if you want to find out more about the use of underscores in Python, I include a link to a real Python video course to get you up to speed with that. Magic module, yes. Well, what the magic is, you will discover a little bit later in this course. So what does the dunder init.py module do? Well, it declares its containing folder as a regular Python package. Now, what does that mean? So which folder is the containing folder? What is a regular package, or what is a package for that matter? And what goes into the dunder init.py module? Well, let me break that down for you. So the containing folder, well, that is the folder that contains the dunder init.py file. I think that makes sense. And so it's that folder that becomes a regular package. So imagine you have the following structure. You have a project folder. So I've included a / behind the word project to show you that it's a folder. So that folder has a subfolder called package. And within the package folder, there is our dunder init.py module. And there are other modules such as main.py. So the folder that contains the dunder init.py module, that is the package folder. So it's the containing folder, and it's therefore the package folder that will become the regular package. What is a regular package? Well, if you take a step back and look at the real Python glossary to see what a package is, well, a package in Python is a directory hierarchy that allows you to organize related modules and sub-packages. Now, a regular package is a package that has the dunder init.py module in its package folder. Now, you might discover there is another type of package called a namespace package, and that one does not have the dunder init.py file in its package folder. Now, given that in this course you are looking at the dunder init.py module, and given that namespace packages don't have that, namespace packages clearly are not part of the scope of this course, but I do include a link in the resource section if you want to find out more about namespace packages. So what goes into the dunder init.py module? Well, it is a magic module. And what does that mean? Well, it means that the contents of that module is easily available to other modules in the package. So therefore, that makes it a perfect spot to stick package level functions such as helper functions or constants and variables for settings for your package, for example. And that also makes it the ideal place to stick metadata, for example, version of your package or the author or the name, etc. Now, the other part of the magic is that the contents is also easily available to package users. So therefore, this is also the ideal spot to stick imports from package or sub-packages to create a coherent namespace. And you will see an example of that later in the course. When is the dunder init.py module executed? Well, it is executed the first time the package is imported and only the first time. Well, with all that knowledge and theory under your belt, I think you're ready to start tackling a real-life example in the next lesson. The example you'll be working on in this course has to do with money. Let's assume that you want to stochastically model your financial surplus over the next 12 months just to see if you have enough money for the next year. So the interface will be that firstly you select an income function, and there will be two to choose from. You then enter the income parameters that are related to that function. And then you do the same thing for the outgo. You select an outgo function. Again, there are two options there. And then you enter the relevant parameters for the outgo function. And then finally, based on the income and the outgo, you will model the surplus. Now, building this basic example, firstly, you'll do that without the dunder init.py module so that you and I can discuss the interface, and you'll realize that to use the interface, the user actually needs to know the folder structure, which isn't very convenient. And also the interface is actually quite tedious in the sense that you have to type quite a bit to get everything going. The third step then, of course, will be to improve this interface using the dunder init.py file. I hope you find that a relatively exciting example, and I will talk you through the code in the next lesson. So you are ready to look at some code. Now, before you do, I would highly recommend that you download the codes. I won't be typing out the code. That would take a bit too long, so you won't be able to follow along, because the intention of this course isn't really to explain how a surplus model works. It is to explain how the dunder init.py module fits into this code and how it changes the user interface. Having said that, of course, I will talk you through the code kind of high level. So if you download the code, you will find a folder called surplus calculator. And that surplus calculator folder has two modules in it, income and outgo. It has a subfolder called simulations, which itself has a subfolder called output, in which you could store output if you so wanted to. You'd have to adjust the code for that, but there you go. That's what that folder is for. And then there is, in simulations, there is the run sims module. The first one to look at is the income module. This one has two functions. The first one on line 4, which calculates a random income based on an income list. So line 5 will show you that it just samples from a uniform distribution between the minimum and the maximum of that list. Line 8 then calculates a fixed income, and maybe bizarrely, the input parameter there is also a list. And then line 9 takes the first element from that list. Now, the reason why the input parameter is a list is just to keep the user interface consistent between functions on line 4 and 8. The second module I'd like to cover is the outgo module, and that has two functions in there that you might find suspiciously similar to the ones in the income module, because they are in fact the same. So on line 4, you calculate a random outgo based on random sampling from a uniform distribution between the minimum and the maximum of your outgo list. And on line 8, you calculate the fixed outgo, which is just the first element of your outgo list. So that's quick. The final module to talk about is the run sims module, and that is in the simulations folder. So here is simulations. If I open up the folder here, you see here is run sims. So what is happening here? Well, on line 3, there is the definition of a module level constant, which is the number of sims. And that is 12 because you will want to sample for the 12 future months. On line 6, then, this is where you actually simulate the surplus. And this function takes 4 input parameters: income function, income input lists, which are the parameters that go with the income function you will select in the user interface. And then there is the outgo function and the outgo input list. Again, the outgo input list holds the parameters that go with the outgo function that you will select in the user interface. And line 9 then just simulates the income for 12 months using a list comprehension, and lines 13 and 14 do the same thing for the outgo. Then finally, in line 17, you return the surplus, which is income minus outgo. So I minus O for I and O from the sim income list and sim outgo list, calculated in rows 9 and 13. So that is the code: 2 income functions to choose from, 2 outgo functions to choose from, and then running the simulations. And crucially, nowhere in the structure is the dunder init.py file. In the next lesson, then, you'll use this code, see what the user interface and the output looks like.